Marissa wonders whether there is an association between the weather and attendance at Great America. She got some data from the office, picked 10 different Saturdays, and analyzed the data. She calculated the least squared regression line to be A equals -14 plus 41t, where A is the attendance at Great America and T is the temperature that day. What does the slope represent in this context? So the slope is 41. So if we think about what this scatter plot would look like, it would be temperature and then attendance. So the slope would be attendance per temperature. So what this tells us is that 41 is the slope, and it's 41 people per temperature, which would be degree. So for each 1 degree greater, the attendance at Great America goes up by 41 people. The residual plot Marissa created is shown at right. On days when the temperature was in the 80s, would you expect the predictions made by Marissa's line to be too high, too low, or pretty accurate? And explain why. So the 80s are right here. So it looks like the residuals for in the 80s are all high. All the residuals are positive, so that means that the predictions made by the line are too low. The prediction is too low because the actual attendance was higher. Or higher than the prediction. What does the least squared regression line predict the attendance to be on a day when the temperature is 95 degrees? So I'm going to plug 95 degrees in for T. So I get A equals -14 plus 41 times 95. And I'm going to do this on a calculator. So 41 times 95 is 3,895. And then I have to subtract 14, which would be 3,881 people. What was the actual attendance on the 95-degree day based on Marissa's data? So on the 95-degree day, let's see, this is 90, so this is 95. So it looks like the attendance, the residual is like -2,467, maybe -7. So that's in thousands of people. So A is in thousands of people. So this number is way too low. Because if the actual value, or if the residual is -7,000 people, then this would be negative people, and that doesn't make any sense. So if we were to, let's see, let's double check our math. So 95 degrees times 41 is 3,895 minus 14. So maybe then we have to multiply this times 1,000. But that would give us a really huge number. That would give us 3,881,000 people, which is huge. That's a ton of people to go to Great America on any given day. So I think that there's some sort of mistake here. But basically the actual attendance here was 7,000 people fewer than predicted. Would you rely on this least squared regression line to make predictions? Explain why or why not. I would not, no. Because the residual plot creates a pattern. It creates this shape. So a linear model is probably not the best fit for this explanation. Because the residual plot makes a pattern, or a shape, a linear model is not a good fit. Maybe a curve, maybe a parabola would be a better fit for this data. All right, for which of the following equations or inequalities is x equals 1 a solution? Show all of your work. So I'm going to plug in 1. So I get 1 plus 3 squared is greater than 4. So that's 4 squared is greater than 4. So that's 16 is greater than 4. That's true, yes. Here I'll plug in 1. 1 plus 5 over 2 equals 2 times 1 squared. 1 plus 5 is 6 over 2 equals 2 times 1, because 1 squared is just 1. 6 divided by 2 is 3 equals 2. No. So A is a solution, but not B. The square root of 1 plus 6 equals 25. The square root of 7 equals 25. That's not true. And then 1 squared plus 5 times 1 plus 6 equals 0. 1 plus 6 plus 6 equals 0. Oh, sorry, 1 plus 5. That'd be 6 plus 6 equals 0. 12 equals 0. Nope, not a solution. So A is the correct, or the only correct answer. James used the distributive property and got the expression 6m minus 12. Name an expression he could have started with. So we could factor out a 6. So we get 6 times m minus 2. We could also factor out a 2. So we get 2 times 3m minus 6. We could factor out a 3. So we get 3 times 2m minus 4. So all of those answers would be correct. Use the graph f of x at right to find the values below. So f of 1, so we go to 1 for x. It's right here, so the y value is negative 1. F of negative 6 for x. 1, 2, 3, 4, 5, 6. So when x is negative 6, y is 2. F of 0 is negative 2. And then f of negative 3, 1, 2, 3, is negative 1. Solve the quadratic equation below by factoring and using the zero product property. So I'll create my box and my diamond. I got x squared, 33. So I need two numbers that multiply to 33x squared and add to 14x. So numbers that I know multiply to 33 are 11 and 3, which also add to 14. So I get x times x, here would be plus 11 and plus 3. So we can rewrite this equation as x plus 11 times x plus 3 equals 0. Now we can use the zero product property. So we get x equals 11 and x equals negative 3. Or sorry, negative 11. and -3.